In this last video on factoring, we're going to talk about the general approach to factoring. The first step here is very important because it will make the rest of your factoring much easier. The first thing you want to do is factor out the GCF. Remember, GCF means greatest common factor, and that's some number and variable combination that goes into all of your terms. Once you factor out the GCF, then you look at the number of terms. If there's two terms, you look at whether it's a difference of squares, so a squared minus b squared, which would factor as a plus b times a minus b. If there's three terms, first you decide, is it a perfect square trinomial? A squared plus or minus 2ab plus b squared would factor as a plus or minus b quantity squared. Is it in the form x squared plus bx plus c, in which case you would look for two numbers that multiply to equal c and also add to equal b? Or is it in the form ax squared plus bx plus c with a not equal to 1, in which case you would use the AC method? So that's if there's three terms. If there's four terms, try grouping. Your third step is check to see if any factors can be factored further, and then check your final answer by multiplying. I have three examples here that we can look at to practice these steps. Factor the polynomial completely. 18x to the fourth y squared minus 50 y squared. So first thing I want to do is figure out if there's a greatest common factor other than 1. So the GCF, in this case, 18 and 50 are both even. So I know 2 goes into both of those. And then there's a y squared in both terms. So I'm going to pull out the y squared. So this is going to be 2y squared. And what's left from the first term, 2 times 9 would give me 18. So I get 9x to the fourth minus 25. Now, the 25 is all I need here because 25 times 2 would give me the 50, and the y squared was already factored out. Now this 9x to the fourth minus 25, this is the difference of squares. So I could write that as parentheses 3x squared quantity squared minus 5 squared. So the 3x squared quantity squared would give me the 9x to the fourth. And so that would factor as 3x plus 5. And I forgot to write my GCF out front, so I'm going to erase that 3x squared plus 5. And I'll start by writing my 2y squared. And then I'll have parentheses 3x squared plus 5 and 3x squared minus 5. And I could stop there. Here I have the sum of a squared term and a constant. And here I have 3x squared minus 5. But because 3 is not a perfect square, I would not consider this the difference of two squares. So I would go ahead and stop there for my final factored form. Here's another example. I have negative 5p cubed plus 5p squared plus 100p. So first step is always look for a greatest common factor. Also, we learned in a previous video, if you have a negative leading term, factor out the negative. So if the leading term is negative, then you're going to factor out the negative. Okay, so I have negative 5, and then there's a p in all three terms. The lowest power on the p is just 1, so negative 5p would be my GCF. So I have negative 5p. Because I factored out the negative, it will change the sign on all the terms. So now I'll end up with p squared minus p, because negative 5p times negative p would give me my plus 5p squared, and then minus 20, because negative 20 times negative 5p would give me plus 100p. So now I have a quadratic in the form x squared plus bx plus c. And so I know it's going to factor as x plus some blank times x plus some blank. And these two numbers here have to multiply to be c and add to be b. So that's the rule I'm going to use up here. I have p instead of x. So let me go ahead and look at the factors of negative 20. So I have 1 and 20, 2 and 10, 4 and 5, and those are it. So I want two numbers that multiply to be a negative 20, but add to be a negative 1. B is negative 1. Okay, so if I do a positive 4 and a negative 5, these multiply to be negative 20. And they add to be a negative 1, which is what I want up here. So write your GCF, in this case, negative 5p, and then factor what's left. So I'll have p plus 4 times p minus 5. All of my factors now are linear, and so there's no more factoring I can do. I can tell I have a p times a p times a p would give me a cubic. So I know that I'm done. Now, if I wanted to check my answer, what I would do is I would multiply it out. So if I wanted to check, I'd have negative 5p, and then I want to FOIL this out, so I would have p squared minus 5p plus 4p minus 20. So that's my FOIL, F-O-I-L, first, outside, inside, last. Combine my like terms, so I'll have negative 5p times p squared minus 1p minus 20. And then distribute, so I'll get negative 5p cubed. Negative 5 times negative 1 gives me plus 5. P times p gives me p squared. And negative 5 times negative 20 gives me plus 100. and then the p would distribute also. That's the original that I started with, so I know I've got the correct answer. Let's do one more example. I have 12x to the 6th minus 40x to the 5th minus 32x to the 4th. Now, I think my GCF in this case for the numeric part would be a 4. 4 goes into 12, 4 goes into 40, and 4 goes into 32. So my GCF would be 4, and then the variable part would be x to the lowest power, so x to the 4th in this case. So I want to factor out the GCF. I have 4x to the 4th. The first term, I would get 3x squared. The second term, I would get minus 10x. And the third term, 32 divided by 4 is 8, so I would get minus 8. And I've already pulled out that x to the 4th, so I don't have any variable on that last term. Now I have a quadratic that's in the form ax squared plus bx plus c, where a is not equal to 1. So I want to use the AC method. I know that it's not a perfect square trinomial because 3 and 8 are not perfect squares. So that's what tells me I need to use AC method. So I have A is 3, B is negative 10, and C is negative 8. So I start by multiplying A times C. 3 times negative 8 is negative 24. And I want two factors that add up to be negative 10. So I have 1 and 24, 2 and 12, 4 and 6. And I want them to add to be a negative 10, but multiply to be a negative 24. So we need a positive and a negative in order to multiply to be a negative. We need a positive and a negative. So I'm looking for two numbers whose difference is negative 10. So for example, if I had plus 2 and minus 12, these multiply to be a negative 24, and they add to be a negative 10. Okay, so now I'm going to split the bx term. My GCF 4x to the 4th is just kind of out front. So I split the bx term. So I'll have 3x squared plus 2x minus 12x minus 8. So I haven't factored yet. I've just split the negative 10x into plus 2x and minus 12x. Now I have to factor by grouping. That GCF is still just coming along for the ride, and I'm just factoring what's inside by grouping. So I'll go ahead and group 3x squared plus 2x together. I have to have a plus between my groupings. So I'll have plus parentheses negative 12x minus 8. Close my bracket. And remember, that's because I had to have a plus between the groups. All right, now I look at each group individually, and in this first group, 3x squared plus 2x, my GCF is just x. In this second group, I want to pull out the negative with my GCF. So my GCF, I'm going to pull out a negative 4. So pull out the negative because the leading term is negative. So I'll have x and I'll have negative 4. Okay, so that GCF of 4x to the 4th is still out front. Inside my brackets, I have x, and then I'll have 3x plus 2. I pulled out a negative 4 from the second grouping, so I'll have 3x plus 2. Remember, with factoring by grouping, what you end up with at this point in the parentheses has to be the same. The reason is that we're going to factor out the 3x plus 2 from these two terms. And so my final answer, I have the 4x to the 4th from the original. I'll have the 3x plus 2, and I'll have x minus 4. This is now fully factored. There's no more that I can do. And that's what I would enter as my final answer. Now, if you wanted to check your answer, you would multiply it out. You'd FOIL the quadratic first, and then you would distribute the 4x to the 4th. So remember your steps. Factor out the GCF first. Then you look at whether you need to use difference of squares, perfect square trinomial, x squared plus bx plus c, the AC method, or factoring by grouping.